Conservation of momentum in 2 dimensions. This is a 3-problem solution. We have a situation where we have 3 balls of silly putty that are coming together at different velocities from different directions. They hit, combine to form one big ball, and then move off together. Your job is to find the final velocity. So you have one kilogram silly putty ball moving 10 meters per second west. This is east. That is west. This is 10 meters per second west, 1 kilogram. This one, 2 kilograms at 20 meters per second north, 20 meters per second north toward the top of the board on the paper, toward the top of your paper. And then this one is 3 kilograms at 5 meters per second, 210 degrees. Here is 0, this is 90, this is 180, and the 210 is an additional 30 degrees from there. So the first thing to do is to sketch the picture of those 3. Make sure you have space for the 3 of them. And the first one I'm going to draw is this one coming in from the south. This is 20 meters per second north, the 2 kilogram object. That's the second one right there. The first one listed is 1 kilogram, 10 meters per second west. 1 kilogram, 10 meters per second west. Then the third one coming in from this direction, 3 kilograms, 5 meters per second, and this angle is going to be 30 degrees. So that is 30 degrees below that west axis, below the negative x-axis. And what we're going to do is put those 3 together, and afterward you have a big object which has a total of mass of 6 kilograms moving at an unknown velocity in that direction. Job is to find that velocity right there. So you have the whole situation all pictured, and what we have to do now is find the initial momentum, because we know that the initial momentum of the whole thing, of that system, is equal to the final momentum, assuming that this is a closed system and there are no net external forces applied to them. So the first thing, the 2 kilogram object, 20 meters per second, that makes 40 kilogram meters per second north. So 40 kilogram meters per second straight up north. And then this one, this is 10 kilogram meters per second west. So 10 kilogram meters per second west, shown by the arrow. And the last one, 15, multiply the 2 together, you get 15 kilogram meters per second at an angle of 30 degrees below the west axis. So this could be horizontal, it could be a vertical plane also, but this is, if you do use the calculator, take the 15 cosine 30, enter, 15 sine 30, enter, you get 13 kilogram meters per second and 7.5 kilogram meters per second. So that is the initial momentum when you put all those together right there, and it's also equal to the final momentum of the whole system. So what we're going to do is put those 3 together over here, and the triangle that we get from that is going to be the same triangle that we would get for this object over here, which is at the end. And we have the 10 and the 13. The 10 and the 13, they go together because they're both west. So we have a 23 kilogram meter per second momentum vector west. And the 40 and the 7.5, one is north, one is south, and those 2 would be combined to get 47.5 gives you 32.5. Here is a 32.5 kilogram meter per second momentum vector north. Combine those 2 to get the momentum at the beginning. It's the same thing as the momentum at the end, and what you need to do is take the second function, square root of 32.5 squared plus 23 squared equals 39.8. So the hypotenuse, 39.8 kilogram meters per second. Angle, inverse tangent. So second function, tangent of opposite over adjacent. 32.5 divided by 23 gives you 54.7 degrees. This 54.7 degrees. And so the initial momentum and the final momentum are both 39.8 kilogram meters per second at 180 minus 54.7 degrees. Gives you 125.3 degrees. This is 0, and this is 90, and that is 125.3. They add up to 180. What we're looking for is not the momentum, because we have the momentum, but the velocity. So the only thing you have to do now is take P is equal to mv. Momentum is 39.8 kilogram meters per second. Mass is 6 kilograms. Find the speed. So you take 39.8 divided by 6, because that's the mass of the whole thing, and you get 6.63 meters per second. Speed, 6.63 meters per second. Direction, 125.3 degrees. So the combination is, which is pictured right here, is now traveling 6.63 meters per second at 125.3 degrees in that second quadrant. Conservation of momentum in 2 dimensions.